In number 3, we're finding the volume of the solid of revolution formed by rotating the region bounded by y equals square root 9 minus x squared. That's part of a circle, radius 3, x equal 1. Actually, let me put a line over here. X equal 1 right here. And x equals 3 about the y-axis. So this is the region, actually. And here's one rectangle. Okay, so we're rotating this region about the y-axis. All right, so we're going to get part of the top half of a sphere, but it has a hole in it, you see. This piece is missing. All right, so we're using the method of shells. So the volume is equal to the integral from 1 to 3, 2 pi. Our radius is x, and this is our height. All right, let's just pull out that 2 pi. All right, now looking at this integrand, we have to decide what method to use. All right, so we can't do the power rule right away because of the square root. And this looks like a u substitution because we have this inner function, 9 minus x squared, and the derivative is minus 2x, and we have an x over here. So we're going to do a u substitution. We'll put u equal 9 minus x squared, du, that's minus 2x dx. Let me write minus 2x dx. And minus 1/2 du is equal to x dx, which is what we have here, x dx. We also have to change over this 1 and 3 to u limits. So let's first do when x is equal to 3. I'll just put a 3 there. When x is equal to 3, u is equal to 0. And when x is equal to 1, u is equal to 9 minus 1, or 8. All right, so now we're ready to switch over. So here we have 2 pi. The integral is from 0 to 8. Don't worry about the fact that the smallest value is on top and the larger one on bottom. We're not used to that, but that's okay. All right, just put it in the same order as these. All right, you see x equals 3 corresponds to u equals 0, so we keep that one on top. Now instead of x dx, we have minus 1/2 du. So let's say we have this minus 1/2 out here. I'll put it in parentheses. Okay, minus 1/2, and there we just have the du. And here we have the square root of u, or u to the 1/2. Okay, outside over here, these two cancels. We have a minus pi out on the outside. And then let's see, we have just integrate u to the 1/2. That's u to the 3/2 times 2/3. And we're going to evaluate between 0 and 8. So when we substitute in 0, we get 0. And now let's substitute in 8. So we have 8 to the 3/2. All right, well, that's not, I'm not going to, that's something we have to approximate using a calculator, so I'm just going to write 8 to the 3/2 times 2/3. So that's equal to pi multiplying through times 8 to the 3/2 times 2/3. And I'll just leave it like that. In number 4, we're rotating the region underneath y equals square root of 2x plus 1 between x equals 0 and x equals 4 about the y-axis. All right, so we'll do the shell method. Okay, we visualize rotating this rectangle, we get a shell. All right, so the volume is equal to 2 pi x f of x dx, and we're integrating from 0 to 4. Just pull out that 2 pi. So we see here we're going to do a linear substitution. All right, with the inner function is a linear function, 2x plus 1, and so it's appropriate to do a linear substitution. So we'll put u equal to 2x plus 1. X is equal to 1/2 u minus 1 du is equal to 2 dx. So I'll write 1/2 du equal dx. All right, so we're ready to start our substitution. All right, so here we have 2 pi. For x dx, we're going to put 1/2 du, so I'll just put the 1/2 over there, and the du here. That's x dx. I just substituted for x dx. Square root of 2x plus 1, that's square root of u, or u to the 1/2. We still have to get u limits of integration over here, so let's do that. Okay, so here we have, again, let's rewrite this, u equal to x plus 1. So let's say when x is equal to 4, we have 4 times 2, 8 plus 1 is 9. And when x is equal to 0, we have 2 times 0 plus 1, that's 1. So we're integrating from u equal 1 to u equal 9. U to the 1/2, let's add 1, so you have u to the 3/2, divide by 3/2, or multiply by 2/3. 1 to 9. Okay, first substitute in 9. 9 to the 1/2 is 3, and 3 cubed is 27. So 9 to the 3/2, that would be 27. All right, so there we have 27 times 2/3. And now let's substitute in 1, so we're just subtracting 2/3. So that comes out to pi times 52 over 3.